y equals absolute value of x is usually something we've studied earlier in math. The graph looks like this. Makes that v. So now it's x equals the absolute value of y, so that just means it's going in a different direction. All y values are positive. All x values are positive because any y value you give us, we're going to take the absolute value of it and make it positive. So the graph looks like this. All x values are positive. Yeah, so it should be over here. This is where x is negative. This is this graph right here. And the graph of x equals 11 minus absolute value of y, this could have some negative values in it. So if you're ever unsure of what a graph looks like without a graphing calculator, you can just make a quick table, plug in some numbers, and the key point is going to be when we switch from positive, when we're near 11 here, because then it's going to change direction. So if you plug in x equals, let's do y equals 11. 11 minus 11 is going to make 0. If you plug in y equals 12, then you're going to get out negative 1. If you plug in y equals 10, you're going to get out positive 1. We should be able to see the shape there. So at x equals 0, y is going to be 11. X equals negative 1, y is going to be 12. X equals 1, y is going to be y is going to be 10. Actually, we haven't seen a switch yet, have we? And then let's plug in y equals 0. You get out 11 for x. Y equals 1. You get out 10 for x. And then y equals negative 1. You'd also get out 10 for x. So that's probably the most important part because that's where it switches. So here's 11. At 10, we're going to have both 1 on the y and negative 1 on the y. So there's a rough sketch of that graph. So this is the area which they're enclosed. They're all straight lines, so this would be a rhombus, I think. But let's do it the calculus way. Let's see. So with my drawing, you can't really tell, but there should be symmetry here because they're all straight lines. They all have the same slope. You know, this is a negative 1, this is a positive 1. So they're all perpendicular, or they're either perpendicular or they have the same slope. So that means we should have symmetry. It should be the same thing up top as it is on bottom. So what we could do is we could integrate this whole function starting from x equals 0 to, we said this is x equals 11. And if you compute that integral, that's going to tell you the area above the x-axis. Well, here, we could break it up where the function changes right here. So to find that intersection point, you plug these into each other and solve. Let's see. But if you do, you're going to get 2 absolute value of y here. We've got x equals absolute value of y. We got x equals 11 minus the absolute value of y. I want to find out where these cross, so I'm going to plug in the top function into the bottom function. So add absolute value of y to both sides. Divide 2 from both sides. And then there's 2 answers there. There's y equals positive 11 over 2 and negative 11 over 2. Those are the y values where it crosses. So that means the x value where it crosses would also be 11 over 2. So this is where they're going to cross. Because if you plug in 11 over 2 in here, yeah, x is 11 over 2. So we can make 2 separate integrals from 0 to 11 over 2. Actually, I think it's a triangle. So that's another way we could bypass calculus probably. This is just a triangle, so you could find the height and multiply that by the base and then times 1/2. Or you could integrate just one area, and then since there should be 4 equal triangles, you can just multiply this by 4. That should be the entire area under the curve. So this line right here, if we want to just consider this and not the entire absolute value, this line has a slope of 1 and starts at y equals 0. So this is just the graph of y equals x here. So that's all we really have to compute. So that's the calculus way. But if your function here is ever really simple, that probably means there's a non-calculus way of doing it, like we've been saying, like a rhombus or using triangles. This is x squared over 2, and we evaluate that from 0 to 11 over 2. So 11 over 2 squared, divide that by 2 times 4, having 60.5 for the area.